Good morning. Thank you for, or good afternoon, I guess, at this point. Thank you very much for having me. My name is Huyen Tuet Dao. I'm an Android developer for about 7 years now. I'm working with Trello, and I love layouts. They're one of my favorite parts of Android development. You know, we talk about and look at these wonderful applications that are innovative and beautiful, and it all comes back down to these XML files. And, you know, in our community of Android, we talk a lot about performance. And generally, when we talk about performance, we talk about Java code optimizations and reflection and enums and things like that. But layouts are extremely important to the performance and the experience of your application as well. And that's the gist of my talk today. I want to talk to you about how layouts can affect your performance and what you can do about it, and why it's important to develop with lean layouts. So today, I'm going to start off again with why lean layouts, why they matter to you and to your user. And we're going to talk about how to find problems when you do experience performance problems in your layouts. And once you find problems, you need to learn how to fix them. So we'll talk about that as well. And then finally, we'll talk about good practices. So I personally don't like to say best practices, because whatever is best for you depends on you, your app, the time of the year, and the alignment of the planet. So I always like to say good practices. So we'll talk about some really good rules of thumb and kind of simple rules to keep for yourself to keep your layouts lean. So why lean layouts? Why do they matter? Well, they matter because performance matters. You've probably heard perf matters a lot in the last couple of years. And when we talk about performance, what are we talking about? Well, what we're talking about is the number of resources that your application uses. Memory, CPU time, battery, etc. Now, the resources that your layouts use is directly proportional to the complexity of that layout. So how do you gauge the complexity of a layout? Well, I tend to think along two lines. First is just the number of views. And it's not too hard to see that the more views you have, the more memory that layout will take, right? Just you need to instantiate those views, you need memory for that. But another way to think about the complexity of your layouts is through the depth of the view hierarchy. Like if you have views, nested in views, that becomes more complex. There's more dependencies there. There's more relationships there. So it makes the processing of that view hierarchy harder. And really what we're talking about in the end is all of these things result in the number and I guess the length of the executions of measure and layout when your view hierarchy is being processed. Now, you could write 100, 1,000 apps where these two methods never have any problems. But if you're writing a particularly intricate or complex interaction, or you have a lot of dense data in that you're trying to display, you can sometimes run into bad performance with measure and layout, and you'll get bad UI performance, you'll get janky and stuttery animations, and really, we now in our Android world, we talk about material design and motion design and animations. So having janky and stuttery animations in UI is just not acceptable. So we have to deal with these things. So when we talk about, jankiness or not jankiness, smoothness of UI, we're talking about user experience. But lean layouts are great for your developer experience as well. And kind of the main point I want to make there is maintainability. So I talked about how performance is related to the resources used by the device. Well, your performance as a developer is also determined by your resources, your mental capacity, your sleep awakeness. And the more complex your layouts, the more of your own resources that you'll use. The more complex a layout is. Imagine like a layout with like 100 views in it. That'll be really hard for you to parse, really hard for you to figure out like which part of the UI correlates to which part of your XML file. So again, if you make your layouts more efficient, with less views, with less nesting, it'll just be easier for you to maintain and for you to read and for you to understand what's going on. And also, in terms of just indentation, right? The more nested your views are, the more that XML file is going to get indented, and views are going to get pushed off and off the screen. So again, keeping your layouts lean and flat is good for you. And just overall stability. Imagine a relative layout, right? Relative layouts are great. They allow you to position things with different constraints, and this to the right of that, above this, in the center of the parent. All of that is powerful and wonderful tools for you to use in your UI development. However, when you start creating layouts that are very complex, where you have views that are depending on each other and interacting with each other so tightly, if you change something, if you just take a view out, that view could look no more like you wanted it to. Things shift that way and that way. So the less complex, the flatter, the more efficient your views are, the more stable they are, and the more you'll be able to refactor and change things without things just blowing up. All right, so before we continue, let's review really quickly how your view hierarchies get laid out and how they actually end up on the screen. So first, what happens is your view must be inflated from your XML layout. It gets instantiated, all your views get instantiated. But before those views actually are drawn on the screen, two things need to happen. The first is the measure layout, in which the platform decides how big those views should be. And second is the layout phase, in which the platform decides where specifically views should have to go. And the way this proceeds is that your view hierarchy is taken, your instantiated views, and Android does a depth-first traversal from parent to children, to siblings, to children, and decides for each view how big it should be. And then the same thing happens for layout. Again, depth-first traversal, going from parent to child, and figuring out where those individual views need to go. So again, you could write 100,000 apps where this isn't a problem, but sometimes problems occur. And where can those problems pop up? Well, again, depth. The deeper your view hierarchy, the more heavily nested things are, the more interdependencies, the more things relate to each other, the more processing is needed to actually handle that layout and put it up on the screen. Another place problems can come up is change. Now, up here I have a little view hierarchy, and say that pink view wants to change size or position. All right, well, it'll go through a measure layout again, but it's not just that view that is going to change size and position. If that view has any siblings, they might also be remeasured and relayed out because they might change in relation to their siblings. All right, but it doesn't stop there. The parent of those two views will probably also change size and position, and then that whole process goes up and up and up all the way to the root. So any change in a child node will result in a whole bunch of invalidations and needing to call measure and layout again, all the way up to the top. And again, more measure, more layout calls, more complexity, more performance problems possibly. Now, the thing is that change, right? So I just mentioned material design, and we talk about motion design and animations, but what is animation but change? So you just can't avoid this kind of problem when you're building your UIs and building your applications. So again, change is something that can cause a lot of problems potentially, and it's something you just can't avoid anymore. All right, so sometimes problems can come from the platform itself. So relative layout. Relative layout is great. It's really powerful. It allows you to position things based on constraints. However, because of that flexibility and that power that it gives you, relative layout will actually automatically call measure and layout twice. So basically, anytime you use relative layout, you're already kind of penalized an extra round of measure and layout. But the thing is, it's not actually just one additional round of measure and layout. It's like doubling the amount of effort you need to render that view hierarchy. So imagine if I had a relative layout and then a relative layout as a child of that first one. That parent will call measure and layout twice, but that child will call them 4 times in total. So the problems are multiplicative, not additive. And again, it's kind of problems like this where, you could write a whole bunch of apps and things are fine, but things will multiply and get bigger and bigger and bigger in ways you don't expect, and that's when you'll start to have problems. And finally, lists. Lists are everywhere in Android. I can't really think of too many apps that don't have some form of list. And lists can be totally great. Recycler view is awesome. But what's a list but a layout that takes a view and then copies it several times over? And that could be totally fine. You might have a really efficient list item, no problems. But if you do have list items that are dense, where you're trying to show a lot of information, that can get pretty complex. And then again, you're multiplying that complexity several times over in that list view. So again, it's a place where problems can occur. So Each of these things in and of themselves can be a problem, can cause you issues with performance. The interesting thing is that you never really find one of these things on their own. They all kind of come together. They all kind of interact. And again, even though you might not feel like you have a problem just yet, when things start to get a little more complicated, when you have more views, more interactions, these things can start piling up, and all of a sudden, boom, you have like performance problems. All right, so problems. How do we find them? So there's a lot of tools available to you to find these problems in your layouts. So one of my favorites is Hierarchy Viewer. It's an SDK tool that you can use to visualize your view hierarchy as a tree structure. It's right in the Android device monitor, and you can use it. The best case is to use it on physical devices running 4.1 and up. There's some reasons for that, like if you run it on any SDK lower, you have to install a view server, things like that. It's a really great tool. There are some numbers that it gives you in terms of runtime. Don't pay attention to them. They're inaccurate. I was told very specifically by someone on the Android team that you should use Hierarchy Viewer as a great tool for analyzing your layouts, but don't use the numbers. So as an example of these different techniques, I created a sample app, and my first activity in my sample app was this really pretty mosaic I did with lots of pictures of food, because I probably made it late at night when I was very hungry. And the view is very beautiful, but as you can see, partially because I have a lot of images, but partially because I created a very inefficient layout, you can see that the scrolling starts to get a little stuttering, a little bit ugly. And so something like this, where there's a lot going on and where you may not be quite sure where things are going awry in terms of performance, Hierarchy Viewer is great for that. So to give you an example of how you use Hierarchy Viewer, you open up Android Device Monitor, and you can go to the Hierarchy View tab. And you go to the windows, and you select the activity that you want to take a look at. And once it loads, you get a couple of different views. You get this really great tree view, which is your entire layout view hierarchy. And you kind of get this zoom-in view where you can look at different nodes in the tree. What's really cool is if you click on each node, you'll get a small preview of your kind of view. And the neat thing is that when you click on a particular node, the preview shown is that the subsection of your hierarchy that is controlled by that node and below. So it's a really handy tool, and it might be hard to see here, but there are some numbers that try to show you how much time measure, layout, and draw take. Don't pay attention to those. But overall, this is a really great tool to give you a very high-level view and understanding of where your hierarchy might have problems. So if you see a lot of those gray boxes in one corner, you could kind of assume that you have a very high density of views there. Or if the tree tends to be very long, you can probably guess that you have a lot of depth in your view hierarchy, and maybe you have to address that as well. So again, a very good tool for just getting a visual idea of where the problems might be. A couple of new things. So the Layout Inspector, it's a brand new tool inside Android Studio 2.2. It's really meant to debug the rendering of your layout, styling properties, layout attributes, things like that. But it has this really great high-level view of the hierarchy that you can just look at and get a good idea of where you might have some complexity in your view hierarchy. So it's in the Android monitor. Again, you get to select which activity is active in your application, and it will give you this kind of, number one on the left, a tree view showing you all the different components in your hierarchy, and then also this kind of layout inspector with this kind of overlay of where they have the outlines of the different views. So it's not specifically geared towards performance, but again, if you're looking at this tree view and you see that you have a very deep hierarchy, or if you happen to see a lot of boxes overlapping in the actual rendering of the activity, you can kind of get a good idea of where you might be having very complex, very nested areas of your view hierarchy. All right, and again, the new blueprint view, and again, just using the tools that we have just in the design view, looking at blueprint view, if you see there's a lot of just a lot of crowding of views or a lot of things overlapping, again, just getting a high-level idea of where your problems might be. So there's a couple more tools that you could use. There's systrace. Systrace is awesome. It generates interactive reports of different process execution data. It actually gives you very specific information about frame rendering. So if we think about a smooth UI, we're generally thinking about a UI that runs at about 60 frames per second. And that means that each frame has to render in about 16.6 milliseconds. And systrace will actually warn you of any frames that take longer than this to run. So that's a really great tool. You can also use dumpsys as an ADB, and what it does, it collects and dumps what it calls interesting information about different system services. There's a specific argument you can use, graphics info, GFX info, that allows you to get kind of performance information related to frames of animation. Marshmallow added another argument called frame stats, and you can get really, really detailed, specific timing information on measure and layout. So you can see the exact fractions of a second when these things occur. So if you really want to kind of measure and kind of analyze things very specifically and numerically, you can use these tools. Or you can use Frame Metrics Listener whenever we get to Android N. It's a brand new API, and it basically is the ADB graphics info frame stats, where it gives you these very specific timing information on each frame, so that you can actually measure the performance at an interaction level in your UI. And the great thing is it's actually a pub/sub API, so it actually sends the information directly to your app window. So you don't have to do it externally in ADB. And another great thing about Frame Metric Listener over the dumpsys is that it's not limited. So the actual frame stats is limited to the last 120 frames of information. Frame Metrics Listener is not limited to that. So again, whenever N comes out, it'll be a really great tool to use to measure the performance of your layouts. All right. So we talked about finding problems. Let's talk about fixing them. And the best place to start when you're trying to fix problems in your layout is lint. I really like lint, or I really hate lint. It depends on the time of day, and it depends on how mean lint is being to me. But in general, lint complains about things that are really not good ideas in terms of performance for your layouts. And when you're first observing problems with performance in your layouts, lint is an excellent place to start to try to solve the little things that it warns you about and try to start your kind of performance fixing up that way. So in my example application, I have this really ugly, nasty layout, which also you probably should not pay too much attention to, other than to see what lint would complain about it. And so one of the first things and one of the biggest things that you should fix in your layouts, if lint complains about it, is useless parents. So it might be a little hard to see, but when you have, say, a layout with a single child that's also a layout, and that extra layout does not provide layout, margins, background, graphical kind of attributes, that layout is useless, and lint will warn you about it. And it is correct. You should remove this useless parent. It doesn't provide anything. It's just more overhead. It's another level in your view hierarchy, and it's just another view to have to process. So again, something that you should definitely take out if lint warns you about them. And another thing lint will yell at you for is nested weights. So linear layout is actually one of my favorite layouts, and weights are an extremely awesome and flexible tool within linear layouts. The problem comes when you start to nest them. Now, again, the way weights work, of course, is that you specify a weight for a particular child of that linear layout, and that linear layout will basically measure every other child in every other of its children, and then whatever is left, it will assign to that child with a weight. And that's fine, but if you nest them, what happens is that weight is kind of like a factor of uncertainty, right? It has to do some calculations to resolve that uncertainty. So when you start nesting the linear layouts and nesting the weights, you kind of multiply that uncertainty. You complicate even more the computations that it has to do to resolve that. So again, nested weights not great for performance. And in my experience, I've done it too, but in my experience, if you have nested weights in linear layouts, there's probably something else you could do. There's always a way to refactor that to kind of get the look you want without nesting the weights. All right, too much nesting. Lint does not like it if you nest your hierarchies too much. And I have a little example from my activity where I have some linear layouts in linear layouts, in linear layouts, in linear layouts. And again, you can see where I mentioned before, where now it's just off the screen because it just nested so deeply. And lint will yell at you. There's actually an environment variable called Android max lint depth or something like that. And I think by default, it's probably 10. So if you nest any of your layouts deeper than 10 levels, lint will yell at you. And it's probably something that you should fix. If you find yourself nesting past 10 levels, you probably should consider refactoring your layout. So say that you make Lint happy, and your application is still not happy, your users are still not happy. The next general guideline I have for you is to simplify and reduce. So as engineers, we know that any problem has multiple number of solutions. When it comes to layouts and performance, opt for the simplest one. And simplest can come in many different forms. It could come in attributes that will access features in particular views. It could come in the shape of other features within like the Android framework, or just even picking different components or different views. So let's take a look at some of those examples. So here I have another application, and at the very top, you'll see an image view and some text. And this is kind of a construct we see all the time in Android, right? Image, text. So when I was first starting Android, I'm pretty sure that if I saw this, I'd say to myself, okay, I have an image, some text. I'm going to do an image view and a text view, and I'll put it in a linear layout, and it'll look great. And it did. But you do not have to do it this way. And there's actually a much more efficient way of doing this by accessing one of the attributes in the text view called the compound drawables. So the compound drawables are attributes that allow you to request that a particular drawable be placed at the top, the bottom, and the left and the right of a text view. It does the rendering for you for free. You can do like padding and different little kind of adjustments to the positioning of those drawables. And it allows you to create the same effect as the linear layout with image view and text view, but with significantly less overhead. So what that'll look like on the left is, my kind of naive implementation of the linear layout with the image view and text view. But just by using the compound drawables and just by using, the other kind of related attributes, I can take my view hierarchy down from 3 views and 2 levels down to a single view and a single level. And this is the kind of like good optimizations that will help you improve your performance and also make your code more readable. And so it's a little hard to see, but the very top image view and text view is done with the naive way, linear layout, and the second text view and image view is done with compound drawables. As you can see, other than positioning, they're exactly the same, and they render just the same. And below here, it's a little hard to see, but I have a more extreme example where I have some text, and I have a drawable both at the top, bottom, left, and right. Now, if I do this with strictly views, I'll end up with like 6 views, like a layout to hold it all, and then 5 separate views inside. But if I use compound drawables, I can go from 6 views down to just 1. So again, using the right attributes and using the features within a view can save you a lot in terms of resources of your view hierarchy. Okay, so here's something a little interesting. So I have here a conversation that I'm trying to render on the screen, and I have like kind of 3 sections of that conversation. I have a big blob of text in one style here. I have another blob of text in another style here, and I have another blob of text here. Now, when I first started Android, I said, well, they're different styles, they're different positions. I should probably just do 3 text views, right? This one here, this one there, this one there, and style them appropriately. But you don't actually have to do that. I can do this, or we all can do this in a single text view. And we do that by using spanables. Spanables are a really great feature of the Android framework, and spanables basically allow you to take a character sequence and apply stylings to just a subsequence of that character sequence. So instead of having 3 separate text views, I can use a spanable, and I have to go to Java code for it. But what I do is I create this spanable string, and then I can assign a certain style, a certain alignment to just parts of that string. And in the end, I just assign that to a single text view, and I get the exact same effect. And so what I get is rather than my kind of original version where I have a layout with 3 text views, I can have a single text view with some Java code as extra. And I go from 4 views and 2 levels down to a single view and a single level. Now, the caveat when you're using spanables is that they might not always work for you. Again, it's in Java code, so you kind of lose the nicety of doing all of your kind of UI and styling within the XML. And also, if you localize your app, you have to be careful with spanables because the subsections of the character sequence are defined by index. So again, if you localize, those indices will change. But if it works, it's a good tool. If it works for you, rather, it's a good tool. Okay, here's just a little something that's a pet peeve of mine, and I know I used to do this as well. Sometimes when you want to apply a background or padding and you kind of want to organize your view in a certain way, you might take some content, wrap it in a frame layout, and then apply the margins and padding and styling or whatever to that outer frame layout. You don't actually have to do this. Frame layout is pretty efficient of its own, but in general, if you're having performance problems, try to compress everything. Don't ever be afraid of setting the attributes directly on your content. So even though frame layout is very efficient, if you just set the padding and set the background on your inner layouts, you will save yourself an extra view, an extra level, and make things just a little bit more efficient. And the result is just the same. So in this example, say that I have 3 text views, and I want to align, say, this purple one here, and then have a blue one vertically aligned next to it, but I want the pair of those to be aligned horizontally with another view. So I remember when I first started Android, I would probably do a vertical layout for the first 2, and then pop that in a horizontal one so they were aligned, the pair was aligned horizontally with the orange one. And there's probably someone in the back shouting, why don't you use a relative layout? Well, you should. And just, I guess the point is that sometimes when you're creating layouts, you do them like as quickly as you can, or you kind of build things incrementally, so things might get a little inefficient. You might be nested when you don't have to be. And it's always good to kind of evaluate and see what layouts are best suited for your particular design or particular structure. And in that example, by just removing that nesting, removing the linear layout within the linear layout, I can go down to a single constraint layout, say, and have my text views sitting inside of those. And I go from 5 views and 3 levels down to 4 views and 2 levels. So again, sometimes it's just picking the right view. So I actually just popped constraint layout into this like a couple days ago. And constraint layout is a great new tool. They just, like Google just announced it at Google I/O just last month. And constraint layout is a great tool in creating leaner layouts. It's geared very specifically to creating flatter, cleaner layouts. And especially at the top level, when you might have a very complex structure and you're not quite sure how to do it efficiently in the kind of traditional linear layout, relative layouts that we had, use constraint layouts. And it is meant to be more efficient than, say, relative layout. So it's definitely a tool. It's in alpha now, so that's a caveat. It is going to go through some growing pains, need some more work, but it is definitely a tool in the future that you should use to create lean layouts. All right, so say that you've picked the best layouts, you've made Lint happy, and you're still having performance problems. You can go with an option that I like to call going custom. I love custom views. And sometimes when you really have severe or just very particular performance problems, sometimes your best option is going with a custom view or view group. Now, the advantage of a custom view group over the platform views is that you have complete control over the measure and layout logic. So if you run into something like relative layout where it just automatically penalizes you that 2 times measure and layout, you can just eliminate that yourself if you're able to define your own layout logic. And again, if that's not enough, you can even go totally custom views where you draw every single thing in your view. Now, the disadvantage, the huge disadvantage, or I guess the trade-off, is that views and view groups of the custom variety are extremely time-consuming and difficult. You lose out on all that wonderfully built-in accessibility and interactions and all that wonderful things that the platform provides you. But if you're having really bad performance problems, it could be an option for you. So if you haven't tried them, I would suggest them. I love them. It's definitely something that you will probably run into when you do Android. If you're kind of hesitant about it, start with simple, straightforward layouts. So if you have data that's static, that doesn't need a lot of interaction, you can play with those custom views. And kind of, if you have content where you can very simply state like where this view should go and where that view should go and where that view should go, you should definitely give custom views a try. But in the end, you have to balance the performance gains with the development effort. If you're spending like hours and hours and hours trying to build a custom view and you're only get just like a minimal gain in performance, that's really not worth it to you. Just try to do what's best for your particular situation. Cool. All right, so good practices. So in general, when it comes to lean layouts, you have to anticipate and develop good habits. So what I mean by anticipate and develop good habits is that as we build our applications and we build different UIs and different interface and different interactions, you kind of start learning what doesn't work for you and what does. And if you're doing a certain kind of structure or style, you might start to kind of remember certain layouts and certain like paradigms that work for you. Like, oh, this layout worked great in this situation, but maybe like custom, I had to do a custom layout for this thing because, of this problem, and so maybe I should use it again. But it's kind of just building your repertoire, building your kind of like toolbox of layout strategies for you and your app and your team. And, we're all on teams. We all have deadlines to meet. We all have, products to push out. So we can't always be completely precise and perfect. And what is perfect for your application, what makes it most performant, can change if your application and your features change. And so you can't always keep up and do the best possible thing. But the goal is to kind of get ahead of it, to do that little ounce of prevention that will help you down the road. And, as you're in the process development, try to use the simplest solutions where possible. I think it was at the ANDEV Summit, and Chet Haas basically said, in terms of the measure and layout, don't do too much stuff. And I think that's a really good rule. Just try not to do too much stuff within your layouts, particularly within an individual view's, measure and layout. And, fewer, flatter views and view groups. Always try to strive to do it as efficiently as possible. Think of it as a challenge. Think of it as an engineering challenge. How can I do this beautiful, gorgeous, innovative UI, but in kind of the most efficient way possible, in the way that is most readable and then most expressive? And don't use relative layout at the root. This also came from Chet Haas and Romain Guy at the Android Dev Summit, and they specifically said don't use relative layout at the root. Basically what happens is as you get higher up in that hierarchy, that the impact of that double layout increases, right, as you have more children, more views to process. So again, don't use relative layout at the root. Probably a good chance to start playing with constraint layout, since that looks like it's going to be the successor to the relative layout in terms of flexibility, but also providing you performance. Don't let problems accumulate. It's hard. We have deadlines. We have to get things done. But always consider when you're in a good break or in a good portion or doing a new UI, try to implement lean, efficient techniques where possible. Again, staying ahead of problems. But in the end, you still, just to repeat myself, balance performance gains with development effort. It's great to use interesting and cool techniques, but try to, again, get the performance gains that you need while spending the minimum amount of development effort required. And that's it. Thank you so much for coming to my talk. And I'll take any questions. Also, yes, as mentioned, I have a YouTube channel called Android Dialogues where we talk with people in the Android community. Please watch. And yeah, thank you so much.
Thank you. Before we get into the Q&A sessions, please keep seated and keep quiet until we are done with the Q&A session. There will be plenty of time for you to move rooms in case you want to join some other speakers in another room. But now for the questions for Win. Are there any questions? Do I see any? Yeah, I see one.
Hi, great talk. What would you say I or a developer should use to measure the performance for a layout in a notification, in a push notification? You can add images, buttons, whatever you want. How would you measure that?
That's an interesting question. Okay. Am I still? Okay, there we go. So that's a good question, kind of a difficult proposition. Sometimes, rather than even specifically using these tools, you could even just do like a print like a log statement, and just using the system.current time milliseconds, and even just doing timing that way. So, like, say, timing like kind of like the or going into the layout and like measuring, setting log statements where you actually measure the amount of milliseconds that pass is kind of a good way to do that. And it's a great way in general to do that, so that you can kind of log the amount of time that these things take as you kind of iterate on that design if you're having problems. So I think that for that particular situation, I probably would do that.
Sorry, would lint work for that? I mean, it would.
Yeah, it definitely would too. Like if you have a layout, it will pop up like lints as well. If you can just view the XML file, you will be able to see the any lint problems that will occur. So okay. For sure.
Thank you.
You're welcome.
Thank you. Do we have any more questions? I don't see any, so thanks again, Win,
Thank you.
for your inspiring talk. And in a few minutes, we are going to continue here with the talk about modular Android development. And yeah, maybe you have time to get yourself a glass of water or coffee or what. In a few minutes, modular Android development on this stage. Thank you, Win.